Welcome you all guys to debugging doubts. In today's topic, let us understand what is T flip-flop. Before we understand T flip-flop, we must know the property of NOR gate. That is, if one of the input of NOR gate is 1, then the output is 0 only. This thing I have said in the previous video, that is RS latch using NOR gate. If you haven't watched my video, then please click on the link above and watch it. Now let's study about T flip-flop. Okay. Can you see the diagram here? This is RS latch using NOR gate, right? Which I have shown in the previous video. If you haven't watched, then please watch it. Here, the two AND gates are extra. That is first AND gate and this is second AND gate. And this is a clock and this is a T, which means T is toggle. Okay. Now, what is a clock? Clock is basically, it changes its value, that is from 1 to 0 and 0 to 1 in a synchronized manner. So purpose of clock is when clock is 1, then only the flip-flop will change its output. Now we'll understand what is Qn and what is Qn plus 1. Okay, so your Qn is previous state and Qn plus 1 is current state. Here, whenever in any flip-flop, when the clock is equal to 1, then only it will take the input and gives the output. That is, flip-flop will be in activate state. But when clock is equal to 0, whatever may be the output in the previous state will remain as the same in the next state. So the output will be in a hold state. Now let us see the block diagram of T flip-flop. Here is the T and here is the output. Okay. So what the T flip-flop do is when T is equal to 0, whatever may be in the previous state, it will have the same value, that is Q itself. Q will remain Q itself. And whenever the T is 1, then whatever may be in the previous state will be negated, that is Q bar. Okay. So we'll fill the truth table by using this analogy. See, when T is 0, okay, for first two cases T is 0, so whatever may be in the previous state will remain same. That is 0 will remain 0 and 1 will remain 1. But when T is equal to 1, output in the previous state will be negated. So 0 will become 1 and 1 will become 0. This is how easily we can fill the T flip-flop truth table. But if you want more details, then I'll explain in the coming slide. Here you can see this is NOR gates diagram and this is RS latch using NOR gate truth table. You must remember for the coming video. This is how you can write the truth table. And if you want to understand the more detailed way about the logical diagram, then I will tell it in the coming part. Now you can see it here, right? So I also consider when clock is 0, okay, and also when clock is 1. Consider the clock as 0 in the first state, okay. When clock is 0, here the AND gate input also will be 0. So whatever the value me of T and Q or Q bar me, the AND gate will give 0 itself, right? So in both cases it will give 0. So this is RS latch. So when 0 and 0 goes to RS latch, the value will be same. That is Q will be Q and Q bar will be Q bar itself. So whenever the clock is 0, whatever value will be in the Qn, same will be represented in the Qn plus 1. That is 0 will be 0, 1 will be 1, 0 will be 0 and 1 will be 1. It does not depend on the t values now because clock is 0. Same thing I have said in the previous section. But when the clock is 1, then only there is some magical happening. Now consider the clock is 1, okay. T value may be something, right, like 0 or 1. So now first we'll consider T value as 0, okay. So both the cases 0 will be passed and output of the AND gate will be 0 itself, right. Then same thing we have reached, that is 0 and 0 in the RS latch. Now what happens? The output will remain same again. So whenever the t value is 0, then the output will also remain same. That is 0 will be 0 and 1 will be 1. Now let us consider only this part. So when clock is 1 and t is also 1, then what the input it will take? 1 into 1 into the q will go here as input, right? So 1 into 1 into q, that is q. And from here q bar will go as input, and this all are 1. So 1 into 1 into q bar. Now, so from here the q bar will come as input to the first NOR gate. So what the NOR gate will do? Q plus q bar whole bar. That's equal to q plus q bar is 1. So 1 bar. So 1 bar is 0. So we got an output as 0. Now this 0 will go to this NOR gate. Now what happens here? Q bar plus 0 whole bar. That's equal to q bar whole bar. That is q. Okay. So now we got q has the output to the second NOR gate. Now this q will go here. So what it happens? Q plus q whole bar. Q plus q is q, and whole bar will come here. That is q bar. You can see I'll erase all the lines. Okay. Now you can clearly visualize. So q has become q bar and q bar has become q. So what it indicates? That q is being complemented, right? So coming to the truth table. So when clock is 1 and t is also 1, then whatever the value in the qn present state, in the next state 0 will become 1 and 1 will become 0. So this is how you can logically understand. So in the truth table we have only considered this part, right? So only this is the main thing, because we know that for clock is 0, we don't need to represent all the things. So when clock is 1, then only it triggers. That is why we used only 4 rows, which is here below. Now coming on to the excitation table. So what it indicates? T is the input, right? And Qn plus 1 is the output. And this is previous output. In truth table, what we say is when input is given, what will be the output? But in excitation table, we say output is given, what may be its input. That we try to analyze in the excitation table. You can see. So Qn is 0 and Qn plus 1 is 0. So Qn value has been changed to 0. Means 0 will change to 0. So in the truth table, you can see 0 to 0 was t value was 0. So we write 0. Now, when q value changes from 0 to 1, so where it is here 0 to 1, then what was the t value? 1. So we have written t value as 1. So from 1 to 0, here it is, right? So 1 to 0, what was the t value? 1. So that is why we written 1, and from 1 to 1, you can see in the second row. So t value was 0. That is why we have written 0. This is how you can construct excitation table from the truth table itself. And it is very much important when we try to solve the counters part. So this was all for today. And if you like my video, then please like it and share it and subscribe it. Thank you all for watching.